Imagine this. Okay. You're trying to land an airplane, and there's this really gentle breeze right at your back, like just 10 knots.
Right, which is nothing. Barely enough to mess up your hair.
Exactly. But because of that one seemingly harmless little breeze, your runway is suddenly 21% shorter.
Yeah, and if you don't do the math on that before your wheels touch the pavement,
You're running out of asphalt, right? You're literally ending up in the trees,
totally. It happens all the time.
which is wild. So today, our mission for this deep dive is exploring what is basically the ultimate cheat code to the greatest outdoor adventure on Earth, flying an airplane.
And we really need to talk about that 10-knot breeze scenario because, people assume flying is just like driving a car in the sky.
Just hit the gas and steer.
Right,
Oh,
right. But it's not. Every single phase of flight is this, well, it's a really rigorous, unforgiving negotiation with the atmosphere.
the atmosphere is always the boss.
Always. It's the one element that separates the people who, just daydream about being a pilot from the ones who actually master the sky. And live to talk about it.
So if you're listening to this as a prospective young pilot, maybe you're a high school student burning hours on Microsoft Flight Simulator or whatever.
Dreaming of that 4K view from the actual pilot seat.
Yes. You probably have this preconceived idea that aviation weather reports are just, like, tedious.
Oh, absolutely. They look like boring lists of letters and numbers.
Just standing between you and total freedom. But understanding those numbers isn't about rules. It's actually a matter of absolute control and survival.
Because you really can't just hit the throttle and go. To understand why we obsess over the atmosphere before we even turn the ignition key, we have to look at the actual physics of an aircraft.
Right. Let's get into the physics.
So an airplane wing generates lift by having a massive airflow over it. We call the speed of that air flowing over the wing your airspeed.
Okay. Airspeed. Got
But
it.
the runway you're taking off from is completely fixed to the ground.
Which brings us back to that breeze we talked about. If you try to take off with the tailwind, meaning the wind is pushing you from behind, it feels like it should help you, right?
It feels like a speed boost in a video game.
Exactly. But it's actually like trying to run up a down escalator.
That is the perfect analogy. Because your wings, they don't care how fast your wheels are rolling across the concrete.
They only care about the wind they feel.
Right. They only care about the air moving over them. If you have a 10-knot tailwind pushing you from behind, your airplane has to achieve a ground speed that is 10 knots faster than normal.
Just to break even.
Just to get the exact same amount of airflow over the wings to generate lift. So you're accelerating. The tires are spinning super fast. The end of the runway is approaching rapidly.
But the wings still don't feel enough wind to fly.
Exactly. You are eating up hundreds of feet of runway space, completely pinned to the ground.
That is terrifying.
And attempting to land with that same tailwind brings an exponential penalty. The physical rule here is that your landing rollout distance increases by the square of the ratio of the tailwind component.
Wait. The square of the ratio. Let's break down the actual physics of that for a second. Why is the penalty exponential and not just, linear?
It all comes down to kinetic energy. Because you have to fly at your required airspeed to keep the plane from falling out of the sky, that tailwind is pushing your physical body and the airplane across the ground much faster.
Okay, so you're moving faster over the pavement.
Right, and kinetic energy increases with the square velocity. So when your wheels finally touch down, your airplane carries a massive amount of extra forward energy.
And small aircraft brakes are incredibly tiny, aren't they?
They're so small, they have to work twice as hard to dissipate all that extra kinetic energy by converting it into heat.
So they just overheat.
Yeah, most of the time, the brakes overheat and fade. Or, honestly, you simply run out of runway before the energy is bled off.
So the wind can literally push you off the runway. But, okay, let's say the wind is totally calm. The windsock is completely limp. You're perfectly safe, right?
You would think so, but actually no. Because the air itself might be secretly robbing your engine of power.
Right, the invisible thief.
Exactly. Let's look at a typical summer afternoon in the mid-Atlantic as the perfect trap for this. It's like 90 degrees Fahrenheit, there's a thick haze in the air, and the humidity is just stifling.
Yeah, it feels like walking through hot soup.
That soup fundamentally alters the aerodynamics of your airplane. Hot air expands, meaning the individual air molecules spread further apart.
So there's physically less air in the same amount of space.
Yes, and high humidity means water vapor has physically displaced some of the heavier, denser oxygen molecules.
Making it even worse.
The result is air that is incredibly thin. Even if your airport is sitting right at sea level, The atmosphere is mimicking the conditions of being thousands of feet up in the mountains.
Oh, is this what veteran pilots refer to as density altitude?
That is the exact term. Density altitude is the altitude the airplane actually feels like it's flying at.
Wow.
Inside your engine, the cylinders have fewer oxygen molecules to mix with the fuel, meaning the internal combustion is significantly weaker.
So your engine produces a fraction of its normal horsepower.
Exactly. And outside, your propeller, which is really just a rotating wing, has less dense air to bite into, so it produces less thrust.
And the main wings have fewer molecules flowing over them, too.
Right, so they produce less lift. You're losing performance everywhere.
So you combine a hot, humid day with a tailwind, and you have essentially gutted your airplane's performance.
You really have.
You'll find yourself at full throttle, rolling down the runway, completely unable to lift off before you hit the trees at the boundary fence. You've lost the game before you even crossed the starting line.
Which is exactly why aircraft performance is entirely at the mercy of the environment.
Man, this feels like a really high-stakes, choose-your-own-adventure game.
It really does.
So, scenario A. You use the tools, you study the atmosphere, you find a smooth, crisp tailwind waiting for you right at your cruising altitude of 6,000 feet.
The dream scenario.
You ride that current, you save a ton of fuel, and you breeze to your destination. You basically surf the sky.
Because you read the environment and leverage the physics to your advantage.
But then there's scenario B. You wing it. You don't check the weather. You arrive at your destination to find a 30-knot crosswind blowing violently directly perpendicular to the runway.
Oh, that's a nightmare.
Attempting to land in that sounds exactly like trying to ride a mechanical bull.
Landing in a severe crosswind is arguably the most physically demanding maneuver a pilot can execute. The airplane is subjected to this phenomenon called weather vaning.
Weather vaning, like the rooster on top of a barn.
Exactly like that. If you picture the aerodynamic center of gravity on an airplane, the main landing gear wheels act as a pivot point.
Okay, I'm picturing it.
There is significantly more physical surface area, like the entire long tail section and the vertical stabilizer behind those main wheels, than in front of them.
So when a massive gust of wind hits the side of the airplane, it catches that large tail section like a giant sail.
Yes, and it violently shoves the tail downwind, which forces the nose of the airplane to pivot aggressively directly into the wind.
Just like the rooster on the barn.
Exactly. Now, put yourself in the cockpit. You're a few feet off the ground, trying to align your tires with the white centerline stripe of the runway, but the airplane desperately wants to travel sideways.
And if you let the tires touch down while the plane is traveling forward at like 70 miles an hour but pointed sideways?
The lateral shear force will instantly snap the landing gear right off.
Whoa. So how do you physically beat the mechanical bull? Your hands and feet have to be working in overdrive, right?
Oh, yeah. You employ aggressive cross-controlled inputs. There's the crab method, where you fly the final approach with the nose intentionally pointed into the wind.
So you're flying forward but looking out the side window to see the runway.
Yeah, you're effectively running sideways. But inches above the pavement, you have to execute what's called the wing low or side slip maneuver.
Break down what the pilot's hands and feet are actually doing at that exact second.
Okay, so you aggressively kick the rudder pedal on the floor to swing the nose straight down the runway, fighting that weather vaning effect.
Pushing it straight.
Right. But the moment you do that, the crosswind will try to blow you entirely off the side of the runway.
Oh.
So simultaneously, you twist the control yoke to bank the wings, dipping your upwind wing directly into the wind to counteract the drift.
Wait, so your hands are twisting the yoke hard to the left, but your right foot is shoving the rudder pedal to the floor.
Yes. You are literally twisting the airplane's control surfaces against each other to force it to fly straight.
You're fighting the flight controls all the way down to the pavement.
All the way down. In a perfect side slip, you actually touch down on just one single wheel, the upwind main gear first. But, there's a physical limit to this. Every aircraft has a maximum demonstrated crosswind component.
Meaning the engineers tested it, and if the wind is blowing 35 knots, but your rudder is only large enough to counteract 20 knots of force.
You lose control.
No.
Full stop.
Yeah, physics taking over.
Yeah. No matter how skilled you are, the airplane simply lacks the physical control authority, the literal surface area on the rudder, to overcome the force of the wind. You will be blown off the runway.
And this highlights why flying isn't just a video game where you can hit respawn if you mess up the landing. If you ignore the crosswind limits, you crash.
You do.
But there is a scenario that is vastly more dangerous, When you look at the NPSB, the National Transportation Safety Board accident data, the absolute deadliest gamble a pilot can take isn't the wind.
No, it's not.
It's the clouds.
The technical term is VFR flight into IMC. Visual flight rules into instrument meteorological conditions.
But the aviation community just calls it scud running, right?
Yeah, scud running.
For anyone listening, imagine you're flying your plane by looking out the windshield, navigating by, rivers and highways. But the clouds ahead are getting lower and thicker.
And instead of turning around, you try to sneak under them.
Right. You dive lower, trying to keep the ground in sight. It is the equivalent of driving down the highway at 100 miles an hour, and someone suddenly throws a heavy, opaque, moving blanket completely over your windshield.
That's exactly what it's like. And instantly, your brain betrays you. When you enter a cloud, you lose all visual reference to the horizon.
You can't see up from down.
Without specialized instrument training, the fluid in your inner ear, which governs your balance, starts sending completely false signals to your brain. This is called spatial disorientation.
So you feel like you're doing one thing,
But you're doing another. You will swear with every fiber of your being that you are flying straight and level, when in reality, you are in a steep, diving spiral toward the Earth.
that is terrifying. Your own senses literally lie to you.
They absolutely do. The NTSB data outlines a grim pattern for scud running. Once a non-instrument-rated pilot loses visual contact with the ground, they typically lose control of the aircraft within about 178 seconds.
Less than 3 minutes.
Yeah. It almost always results in a high-speed structural failure from overstressing the airframe in a dive, or a CFIT.
Wait, CFIT, what does that acronym stand for?
Controlled flight into terrain.
Oh, wow.
It means there's absolutely nothing mechanically wrong with the airplane. The engine is running perfectly. But because the pilot is completely blinded by the clouds and spatially disoriented,
They just fly a perfectly functioning airplane directly into the ground.
into the side of a mountain, a radio tower, or simply straight into the ground, yes.
So we have established the stakes, we have the mechanical bull on the runway, and the blinding blanket of the clouds. How do you avoid them?
Well, you have to learn the secret language of the sky.
Yes. The meteorological reports and terminal forecasts. And when you first look at a meteorological aerodrome report, it literally looks like a terrifying math equation that someone just smashed into a keyboard.
It really does look like nonsense at
But
first.
once you know how to decode it, it gives you superhuman vision. You can see the atmosphere hundreds of miles away without even leaving your chair.
Because it's the most dense, highly efficient way of transmitting a massive volume of environmental data.
Okay, let's do a decoding exercise right now. I have a real string of code here from a weather report.
Let's hear it.
It reads 22015G25KT, then a space, plus TSRA space, OVC010CB. To a normal person, that is absolute gibberish.
But to a pilot, it paints a vivid, three-dimensional picture of violence. Let's break down the mechanics of that code.
All right, hit me.
The first block is the wind. 2 0 is the compass heading the wind is coming from. 15 is the sustained speed in knots.
Okay, 15 knots.
The G means gusting to 25, so you have a 25-knot erratic slamming wind.
Yikes. What about the plus TSRA part?
The plus sign designates high intensity. TS stands for thunderstorms. RA is rain. So heavy thunderstorms and rain.
And then the final boss of this code, OVC010CB.
Right, OVC stands for overcast, meaning the sky is completely blocked out. The 010 dictates the base of those clouds is sitting ominously low, just 1,000 feet above the ground.
Just 1,000 feet up.
But the critical warning is the CB. That stands for cumulonimbus.
Oh, those are the massive, towering, anvil-shaped storm clouds, right?
They are. They're basically vertical atmospheric engines. Cumulonimbus clouds pull moisture up from the surface and fire it tens of thousands of feet into the freezing upper atmosphere.
It's a massive energy.
They contain extreme updrafts and downdrafts moving at thousands of feet per minute, throwing massive hailstones. The kinetic energy inside a CB can literally rip the aluminum wings off a small plane in midair.
You just decoded the Matrix. From a few random letters on a screen, we went from gibberish to seeing a terrifying metal-bending thunderstorm park directly over the runway.
And, the pilot community relies on a whole subculture of slang built around these reports, too. You might wake up, decode the weather, and realize you have a CAVU morning. CAVU.
Clear above, visibility unlimited.
Exactly. Clear above, visibility unlimited.
The ultimate green light. But the intelligence gathering doesn't stop with automated ground sensors, does it?
Hmm.
There is this real-time multiplayer co-op mode to this that I find fascinating. Pyera Ps.
Ah, pilot reports. Yes. A PIREP is an actual human observation from a pilot currently strapped into a cockpit flying through the air mass.
So you could be on the ground plotting your route or flying halfway to your destination, and someone 50 miles ahead of you radios air traffic control.
And says, hey, the automated forecast completely missed this, but there is severe turbulence at 6,000 feet that is violently throwing my plane around.
Or I am picking up a thick layer of clear ice on my wings inside this cloud.
Right. They are providing tactical, real-time intelligence. That pilot is using their aircraft as a probe to help everyone else in the sky update their strategy.
It is pilots keeping other pilots alive. I love that. So you have the cheat codes, you can read the secret language of the METAR, you understand the physics of density, altitude, and kinetic braking energy. So who is the ultimate master pilot?
Well, it is generally the complete opposite of what Hollywood portrays.
Yes. In the movies, the best pilot is the maverick action hero. The one who fights their way through the hurricane, sweating, alarms blaring in the cockpit, ripping the controls around, and somehow landing a burning plane.
Which is absurd. If you are relying on heroic piloting skills to survive a flight, you have already made a cascade of terrible decisions.
Right, you messed up hours ago.
The truly smart, most respected professionals in aviation are the ones who look at the METAR, see the cumulonimbus clouds and the 30-knot crosswind, realize the physics are stacked against them.
Tie the airplane down to the ramp and go grab a burger.
Exactly. They just go grab a
They
break.
don't even turn the key.
That is the go-no-go decision. And it's a continuous psychological process built around the 5P framework. You evaluate the plan, the plane, the pilot, the passengers, and the programming.
And the most dangerous variable in that list is usually the passengers, right? Because of the psychological pressure they introduce.
The aviation term for it is get-there-itis.
Get the itis.
It's this overwhelming external pressure to complete the mission. You have friends in the back seat, you have a hotel booked, people are waiting for you at the destination.
You feel like you can't let them down.
The easiest, most objective time to cancel a flight is before you ever load those passengers into the cabin. Once they are seated, the pressure to just push through the weather becomes fatal.
Which is exactly why pilots create what is known as a personal minimums worksheet.
Right, because the Federal Aviation Administration sets the legal baseline. For visual flight, the SAA might dictate that it is legal to fly if you have 3 miles of forward visibility.
But if you're flying at 120 miles an hour, 3 miles of visibility means you only have about 90 seconds to see a radio tower and maneuver out of the way.
Which is terrifying for a newly minted private pilot.
Yeah, that's no time at all.
So just because it is legal does not mean it is safe for you. You sit down when you are calm and on the ground, and you write down your personal minimum. You might decide that you require a minimum of 5 miles of visibility.
So if the forecast predicts 4 miles,
You stay on the ground.
you don't rationalize it, you don't negotiate, you go eat the burger.
You never gamble with the weather
Yeah.
because the atmosphere always wins. You stack the deck by knowing your physical and psychological limits and having the iron discipline to stick to them.
So for you listening, as you plot out your path to getting your license, remember this. Studying the weather isn't about memorizing a bunch of restrictive rules designed to keep you on the ground.
It's the exact opposite, actually.
Understanding these physics is your ultimate tool for freedom. It puts you in complete control, ensuring that every time you unchalk the wheels and strap into that seat, your 4K view from the office is safe and spectacular.
Before we wrap up, I want you to consider a final scenario. We spent all this time looking at iPads, studying high-resolution radar, and decoding METARs to predict what the atmosphere will do.
Right, all the tech.
But meteorology is ultimately chaotic. The next time you step outside and look at a towering puffy cloud on a humid afternoon, ask yourself, if the digital radar goes completely blind and the battery on your iPad dies mid-flight, do you know how to read the physical sky well enough to save your own life?
That's a huge question.
Because a smooth, lens-shaped lenticular cloud hovering over a mountain, that's a visual siren for violent turbulence. The sky never lies. It's constantly broadcasting its intentions. You just have to learn its native tongue.
It's all right there above you. You just have to start looking up. Catch you next time.